section 10.2 operations with matrices. Let's start with the first example. They're telling you on the first one, two matrices are if all their corresponding entries are equal. That means if you have two equal matrices, so if you have this matrix A, B, C, and D, these two matrices are equal if they have exactly the same entries. That means 5, let's say here, 6, 3, 2. So you see we have 4 entries here, we have 4 entries here. In this case, the value of A equals 5, the value of B equals 6, the value of C equals 3, and the value of D is going to be equal to. So in this case, I just want to understand what's the meaning of two equal matrices. So the here is going to be equal if they have exactly the same corresponding entries. For the second one, when performing matrix operation, real numbers are usually referred to the real numbers, which is gonna say scalars. So when you see a scalar, that means this is a real number, it's going to be multiplied for the matrix. For example, this is for number 1. For number 2, just an example, if you have 5 and matrix A, this one is called scalar. So you're gonna call it scalar. So for number 2, we're gonna call scalar. The wrong. This one is called scalar. This is for number 2. For number 3, a matrix. For number 3, a matrix consists entry of zeros called all the numbers here is called zeros is called zero matrix and is denoted by O. So this is the zero matrix. For example, for that, like if you have this matrix, all entries here is zeros. This is called zero matrix. Zero matrix. So now, the n times n matrix consists of 1 in the main diagonal and zeros everywhere else. Let's do an example like this. If you have this matrix, 1, 0, 0, 1. You see the main diagonal here. Here is the diagonal 1, and every entry is here on the top and the bottom equal zeros. Or if you have 3 times 3 matrix, it's going to be 1, 0, 0, 0, 1, 0, 0, 0, 1. This is called identity matrix. Here's an example of 3 times 3, and this is with dimension 2 times 2. So this is called identity matrix. For example, 5, sorry, this is example 5, not 6. So for example 5, they're telling you solve for x and y. We need to find the value of x and value of y. And if we look here, we have 2 equal matrices. It means they have equal entries. So if you look here, we have -3 equal -3, and -2, and here is 9 equal 9. In this case, that means x is going to be equal -2, and y is going to be equal y equal 21. So that's what we have to write down. So x is going to be equal -2. We have -3 here. So x equal -2 and y is going to be equal 21. That's what we have to type for this example. So here's -2 and here's going to be 21. That's it for this example. For example 6, we're going to do the operation for the matrices. So let's check for example 6. If possible, find. We have two matrices A and B. We need to find A plus B. So we can add these two matrices because it's exactly the same dimension. This is 2 times 2, and this is 2 times 2. So for A, to find A plus B is going to be, we're going to add -1 plus 2. So let's first of all write down the matrix. 2, -1, plus the matrix B, which is 2, 1, -1, 9. So the result is going to be -1 plus 2 is going to be 1. 1 plus 1 is going to be 2. 2 minus 1 is going to be 1. And -1 plus 9 is going to be 8. So A plus B is going to be 1, 2 here, and 1, 8. That's it for A. Let's check B. They're telling you A minus B. Be careful with the B. The second one, A minus B. It's going to be equal. Here's A, -1, 1, 2, -1, minus B, 2, 1, -1, 9. So the result is going to be -1 minus 2. -1 minus 2 is going to be -3. 1 minus 1 is going to be 0. 2 minus -1. 2 minus -1. So negative times negative positive. 2 plus 1 is going to be 3. And -1 minus 9 is going to be -10. So be careful when you have minus between two matrices. So the result for A minus B is going to be -3. And here is going to be 0, 3, and -10. Now 2 times A. Remember when I told you the scalar? 2 times A, this is the number 2 is the scalar times the matrix. So for C, they're telling you to find 2A, which is mean equal 2 times the matrix A, which is -1, 1, 2, -1, which is mean equal. You're going to multiply 2 times -1 is going to be -2. 2 times 1 is going to be 2. 2 times 2 is going to be 4. And 2 times -1 is going to be -2. So the result is going to be -2, 2, 4, and -2. This is for C. For D, we have two scalars. We have 2 times A minus 5 times B. So it's mean equal 2 times the matrix A, which is -1, 1, 2, -1, minus 5 times the matrix B, which is 2, 1, -1, and 9. So that's mean this one is going to be equal. Simplify it first. 2 times -1 is going to be -2. 2 times 1 is going to be 2. 2 times 2 is going to be 4. And 2 times -1 is going to be -2. Minus. The second one is going to be -5 times 2 is going to be -10. -5 times 1 is going to be, if you do this one, you have to change the sign. If you keep the negative sign, you have just to multiply the 5. So which option you're going to use? Let's say 5 times 2 is going to be 10. I'm going to keep the sign. 5 times 1 is going to be 5. 5 times -1 is going to be -5. And 5 times 9 is going to be 45. So just distribute the 5. Keep the negative sign. If you want to distribute -5, you have to change this one to positive, to plus. So this one is going to be equal -2 minus 10, -2 minus 10. So it's going to be -12. 2 minus 5 is going to be -3. 4 minus -5, that means 4 plus 5 is going to be 9. And -2 minus 45. So -2 minus 45, you're going to add these together. It's going to be -47. That's it for this one. So here we're going to type -12, -3, 9, -47. That's it for this example. We got it right. Let's move to example 7. We're going to do the same steps with example 7. For example 7, we're going to do the same thing with example 6. If you remember example 6, the first thing before I start adding, so for A, if we need to find A plus B, we need to check the dimension. The dimension for this matrix, we have 2 rows and 3 columns. And the dimension here, we have 2 rows and 2 columns. They are totally different dimensions. So we can't add these two matrices. So I can't find the addition. So in this case, we're going to type here. I think we have to do it like this. We're going to type impossible. Yes, possible. Because you can't add these together. So just type impossible. The second one, we can't also add or minus because they have different dimension. So A minus B. So you can't do the addition. You can't do the minus between these two matrices. So the same thing, we're going to type here impossible. Okay. For C, it's multiplied by scalar. So we have 5 times A. We can't do that because a scalar is a real number times the matrix A, which is 5, 0, 2, -5, and -4, the 0. And the result is going to be 5 times 5 is 25. And this is 5 times 0 is going to be 0. 5 times 2 is going to be 10. 5 times -5 is going to be -25. 5 times -4 is going to be -20. And 5 times 0 is going to be 0. So we can multiply by a scalar because it's only one matrix. We don't have to change the check the dimension. And here's 10, -25, and here is -20, and 0. What about D? The same thing. We can multiply 5 times A. And we can multiply 3 times B. But we can do the minus between these two. So that means it's also impossible for D. Because we can do the scalar, but we can't do the minus because these two matrices with different dimension. So we're going to type here impossible. So we got it right. Let's move to example 8. Example 8, solve x in the equations where a and b, we need to find the value of x. So for example 8, we need to find the value of x. That means we're going to solve this one. So the first step, we're going to plug in matrix A and matrix B and check the first thing. The dimension of matrix A is 2 rows, 3 columns. That means I can do the addition. We need to check the dimension. We have exactly the same dimension. That means we need to find the value of x. So 2x is going to be equal to 2 times the matrix A, which is -4, 3 and 2, -1, 2 and 1, minus matrix B, which is 1, 5, -4, and 2, 5, 3. So the first thing here is 2x equal. I'm going to multiply the scalar. So 2 times -4 is -8. 2 times 3 is going to be 6. 2 times 2 is going to be 4. 2 times -1 is going to be -2. 2 times 2 is going to be 4. And 2 times 1 is going to be 2. This one is going to be minus 1, 5, -4, 2, 5, and 3. Now we're going to do the minus between these two matrices. That means 2 times x is going to be equal -8 minus 1 is going to be -9. 6 minus 5 is going to be 1. 4 minus -4, 4 minus -4. So it's going to be 4 plus 4. That means 8. Now -2 minus -2 is going to be -4. So be careful when you do the math. 4 minus 5 is going to be -1. 2 minus 3 is going to be -1. Now I need to find the value of x. This is the variable. Remember before, when we're working with the equations, if we have 2x equal 4, if I need to find the value of x, I'm going to divide both sides by 2. We can do the same thing here. I need to find the value of x, so I'm going to divide both sides by 2. Or you can multiply by 1/2. So that means x is going to be equal 1/2, which is the same thing, -9, 1, 8, -4, -1, -1. Or you can divide the whole thing by, you can write it down as the matrix divided by -2. Sorry, by 2. You can type it like this, or you can type it like this. Divide by 2. So that means x is going to be equal -9 divided by 2. Just type it 9/2, -9/2. 1 divided by 2. Do not type it as a decimal number. 8 divided by 2 is going to be 4. -4 divided by 2 is going to be -2. -1 divided by 2 is -1/2. And -1 divided by 2 is -1/2. So that means this is the result. This is the value of x. We're going to type everything here. So we type everything. Let's check our solution. We got it right. Let's move to number 9. For number 9, we're going to do the multiplication between two matrices. Let's check what's the important step when you do the multiplication between two matrices. With addition and subtraction between two matrices, you just have to check the dimension for these two matrices, exactly the same dimension. Let's check if we have multiplication between two matrices. For example 9, we need to find the multiplication between A and B. A times B equal. Before you start finding the multiplication between A and B, this is really important step. You have write down the dimension for the first matrix A, 3 rows and 2 columns. And the dimension for the matrix B, 2 rows and 2 columns. You can do the multiplication if you have exactly the same numbers here. The columns for the first matrix equal the rows for the second matrix. If you have exactly the same number, that means you can do the multiplication. If you have different numbers, you can't do the multiplication. The new matrix is going to be with dimension 3 times 2. So the new matrix is going to be 3 times 2. This is the dimension for the new matrix. Because I can do the multiplication, now I can write down the dimension. So I'm going to keep in my mind, I have to get 3 rows and 2 columns. So A times B is going to be, let's check the steps. So the important steps. The first thing, I'm going to multiply the first row with the first column. The first row with the first column. Then the first row with the second column. So when I'm doing the multiplication, the first row with the first column is going to be -1 times 5 plus 7 times 0. This is the first element here. Then I'm going to do the first row with the second column. The first row with the second column is going to be here. -1 times 4 plus 7 times 6. I'm just doing the operation. I didn't do the math. Just write down everything. Then next step, I'm going to write down the math. Now, we're done from the first row. Let's go to the second row. The second row with the first column. So here's going to be -3 times 5 plus 9 times 6. The second row with the second column. So it's going to be -3 times 4 plus 9 times 6. I did mistakes here. 9 times 5. -3 times 5 and 9 times 0. Then here it's going to be -3 times 4 and 9 times 6. Now we're gonna work with the third column, or third row. The third row is going to be 0 times 5, 4 times 0. So plus 4 times 0. Then the third row with the second column, 0 times 4 plus 4 times 6. So now we just have to do the math. So this one is going to be equal. This is 0, so it's going to be -5. This is 0, here is going to be -15. This is 0 and this is 0, so it's going to be 0. Let's check here. This is 7 times 6 is 42. That means 42 minus 4 is going to be 38. So here's going to be 38. The second one is going to be 9 times 6 minus 12. It's going to be 42. So here is going to be 42, the second number here. This is 0, and so here is going to be 4 times 6 is going to be 24. So here, 24. So check what we have here. Here is the multiplication between A and B, and the dimension is 3 rows and 2 columns. That's it for this example. So we're just going to type here -5, 38, and here is -15, and here is 42. Here is going to be 0 and 24. And the dimension for the matrix is going to be 3 times 2. That's it for this example. Here we go, we got it right. Let's go to example 10. We're going to do the same thing with example 10. We need to check if we can do the multiplication between A and B. So if you look to the dimension of A, the dimension of A is 3 times 2 column. And the dimension, this is for A. The dimension for B is 3 rows and 3 column. So check these two numbers. These two numbers are not equal. That means we can't do the multiplication between these two matrices. So you're just gonna type impossible. So you're gonna type here impossible. So types here impossible, impossible, and impossible. Let's check our result. There we go, that's it. So that's how we're gonna check. Before you do the multiplication, between two matrices, you have to check the dimensions if you can do the multiplication or no. So for example 13, again, we're gonna check the dimension before we start doing the multiplication, because they ask you the first one, find A times B. For A, they ask you to find A times B. So the dimension for the first matrix is 2 times 2, and the dimension for the second matrix is also 2 times 2. So we have exactly the same numbers here. That means our new matrix is going to be 2 times 2. So let's check A times B. Again, this is only to find the dimension for A times B. If you want to do B times A, you have also to check the dimension. So that means this one is going to be equal the first row times the first column. So it's going to be 1 times 4 plus 3 times -1. The first row times the second column. So it's going to be 1 times -1 plus 3 times 6. Now, the second row with the first column. So 2 times 4 plus 3 times -1. Now, the second row with the second column. So it's going to be 2 times -1 plus 3 times 6. That means the result here is going to be 4, 1 times 4, 4 minus a 3 is going to be 1. 8 minus a 3 is going to be 5. This is -1. This is 18. So 18 minus 1 is going to be 17. And here, this is 18 minus 2 is going to be 16. And the dimension for the new matrix is 2 times 2. That's it for the first one. So we're going to type here 1, 17, 5, 16. Now we need to check B times A. So B times A. Before I'm doing that, I'm going to write down the matrix again. So B equal, because I need to check the dimension, always do these steps. And the matrix A is 1, 3, 2, 3. So the dimension for this matrix is 2 times 2. The dimension for this matrix is 2 times 2. That means I can do the multiplication because I have exactly the same number. So B times A is going to be the first row times the first column. So 4 times 1 plus -1 times 2. The first row times the second column. So it's going to be 4 times 3 plus -1 times 3. And now the second row with the first column, so -1 times 1 plus 6 times 2. The second row with the second column, so it's going to be -1 times 3 plus 6 times 3. That means the result is going to be 4. -1 times 2 is going to be -2, so 4 minus 2 is going to be 2. -1, and here is 12. 12 minus 1 is going to be 11. 12 minus 3 is going to be 9. And this is 18 minus 3 is going to be 15. So that means A times B is not equal B times A. So we're going to type here 2, 9, 11, 15. The next one, we need to check A squared. A squared, it means A times A. You're going to multiply the matrix times itself, and you can do the multiplication. Also, you can check the dimension if you can do the multiplication or no. I'm going to write down the matrix A here. 1, 3, 2, 3. And I'm going to write down again this one, so I'm not going to do mistakes. 1, 3, 2, 3. The dimensions, 2 times 2. And here also 2 times 2. So we can do the multiplication between these two matrices because we have exactly the same dimension. So now the result is going to be A squared equal the first row times the first column. So it'll be 1 times 1 plus 3 times 2. And here is going to be the first row with the second column. So it'll be 1 times 3 plus 3 times 3. The second row with the first column. So 2 times 2 with the second column. Sorry, the first row with the first column. So 2 times 1 plus 3 times 2. The second row with the second column. So 2 times 3 plus 3 times 3. That means the result is going to be the new matrix. This is 1 plus 6 is going to be 7. This is a 3 plus 9 is going to be 12. 2 plus 6 is going to be 8. 6 plus 9 is going to be 15. That's it for this matrix. A squared is going to be 7, 12, 8, 15. So I was typing in different example. So this is 1, 17, 5, 16, For the B times A is going to be 2, 9, 11, 15. And for the A squared is 7, 12, and 8, 15. We got it right. This is the solution for example 11. Let's check. We're going to do exactly the same thing with example 12. Let's do example 13. I post the result for example 11 here, so I'm going to try to solve this one. Let's work on example 13. So the first thing for this example, let's find A times B. So A times B. So the dimension for A is the 3 rows and 2 columns. Dimension for B is 2 rows and 2 columns. So we have exactly the same number here. That means I can do the multiplication. So A times B is going to be equal the first row times the first column. So 4 times 1 plus 4 times 1 plus negative 4 times 0. Now, the first row with the second column, 4 times 0 plus negative 4 times 1. Now, the second row with the first column, so negative 2 times 1 plus 0 times 0. The second row with the second column, so negative 2 times 0 plus 0 times 1. Now the third row with the first column, so 5 times 1 plus 8 times 0. The third row with the second column is going to be 5 times 0 plus 8 times 1. That means the result is going to be, let's write down here. This is 0, so it's going to be 4. This is 0, so it's going to be negative 4. This is 0, so it's going to be negative 2. This is 0 and 0. This one is 5. This is 0, so it's going to be 5. This is 0, so it's going to be 8. Why? We got exactly the same matrix A. Because if you look to this matrix, is the identity matrix. If you multiply A times the identity matrix, of course, it's going to be A. So this is for the first one. If you check the B, we need to find B times A. B times A. The dimension for B is 2 times 2. The dimension for A is 3 times 2. If you look to these two numbers, they are not equal. So we can't do the multiplication. That means this is impossible. For the C, they ask you to find A squared, which is equal A times A. So I'm gonna write down A here, and here is the matrix A here. The dimension for the matrix A is 3 times 2. The dimension for the matrix A is also 3 times 2. Let's check these two numbers. They are different numbers, so we can do the multiplication. That means for the first one is going to be 4, negative 4, and here is negative 2. Here is going to be 0. And here is going to be 5, 8. And for B, we have to type impossible. And for C, we have to type also impossible. That's it for this example. You got it right. Let's move to example 14. We're going to do exactly the same thing. So let's check example 14. The first thing we need to find A times B. A times B. So if you look to this matrix, the dimension for matrix A is 1 row, 1, 2, 3, 4, and 4 columns. So 1 times 4. The dimension of B is 1. How many rows? 1, 2, 3, 4. So 4 rows and 1 column. We have the same number. That means we can do the multiplication. So let's check how much is going to be the result. A times B is going to be the first row times the first column. So 2 times 4 plus 1 times 2 plus 3 times 0, because I'm multiplying the first row with the first column. And it's only 1 row and 1 column. And here's going to be 4 times 1. So the result is going to be, this is 8, 10, plus 4 is going to be 14. If you look the new matrix with dimension 1 row and 1 column. So here is 1 row and 1 column. So this is the dimension 1 times 1. So this is the first one. We're just going to type here 14. For the first one. For the second one, if we multiply B times A, I'm going to write down B first, 4, 2, 0, 1, and A equal 2, 1, 3, 4. Let's check. Can we do the multiplication? The dimension for the A for B is 1, 1, 2, 3, 4, 4 rows and 1 column. The dimension for matrix A is 1 column and 1 rows and 4 column. The same thing, we have exactly the same number, and our new matrix is going to be with dimension 4 times 4. That means B times A is going to be 4 times 4. Let's check that. The first row times the first column. 4 times 2 is going to be 4 times 2. The first row times the second column. So 4 times 1. The first row times the third column. So it's going to be 4 times 3. The first row times the fourth column is going to be 4 times 4. Now the second row times the first column. So it's going to be 2 times 2, and 2 times 1, and 2 times 3, and 2 times 4. Then it's going to be 0 times 2, 0 times 1, 0 times 3, and 0 times 4. And the third one is the last one is going to be 1 times 2, 1 times 1, 1 times 3, and 1 times 4. So our new matrix is going to be 8, 4, 12, 16. And the second one is going to be 4, 2, 6, and 8. Then it's going to be 0, 0, 0, 0. And here is going to be 2, 1, 3, 4. That's it for this example. So you have to close the bracket from here. And the dimension is 4 times 4. So we're going to type here for this matrix 8, 4, 12, and 16. The second one is going to be 4, 2, 6, 8. And here is going to be 0, 0, 0, and 0. One more row. And here is going to be 2, 1, 3, 4. 3 and 4. Let's check if we need to find a squared. A squared, which is mean A times A. So the matrix A is 2, 1, 3, 4 times the same matrix 2, 1, 3, 4. The dimension for this one is 1 row and 4 column. The dimension for this one, 1 row and 4 column. If you check these two numbers, they are not the same. So we can't do the multiplication. So that means this is impossible for the set. The last one, you just have to type impossible. We got it right. Let's move to the last question, 15. Evaluate the expression. So check here, we have addition and multiplication. So it's up to you the way you did it, which is the easiest way. You can check, can we add these two matrices? Yes, because they are exactly the same dimension. Then I'm going to multiply this matrix with the result of this addition. So if I look to, here's the addition with the same dimension. So that means I can combine these together as 2 plus negative 3 is going to be negative 1. 0 plus 3 is going to be 3. 0 plus negative 2 is going to be negative 2. Negative 4 plus 4 is going to be 0. Negative 5 plus 0 is going to be negative 5. And the 3 plus negative 4 is going to be negative 1. And here is the second matrix, which is 0, 5, negative 2. And here 1, 2, and 4. If you check the dimension for this matrix, we have 3 rows and 2 columns. For this one, we have 2 rows and 3 columns. So we can do the multiplication because these are equal. And the new matrix is going to be with dimension 2 times 2. So let's do the multiplication. So the first row times the first column, 0 times negative 1 plus 5 times negative 2 plus negative 2 times negative 5. Need more space? Yes, maybe enough. Now the first row times the second column is going to be 0 times 3 plus 5 times 0 plus negative 2 times negative 1. Now, the second row with the first column, which is 1 times -1 plus 2 times -2 plus 4 times -5. And the second row with the second column, so it's going to be 1 times 3 plus 2 times 0 plus 4 times -1. So the result is going to be, this is 0, -10, +10. 5 times -2 is going to be -10. -2 times -5 is going to be 10. Add these together, it's going to be 0. This is 0, this is 0. -2 times -1 is going to be 2. This is -1. This is -1. And here is -4. And here is -20. So it's going to be -25. And here is going to be, this is 0. This is 3 minus 4. 3 minus 4 is going to be -1 with the dimension 2 times 2. So the result is going to be this matrix with 0, 2, -25, and here is going to be -1. We got it right. That's it for this section.